Hello everyone and welcome to my final year project presentation, which is image difference-based facial expression recognition using local binary pattern. My name is Muhammad Ismail bin Ibrahim and my supervisor is Dr. Tan Lit Ken. So let's get started. Facial expression recognition is a technology that has been developed in the 1995 and has since been used and implemented in our daily lives. From unlocking smartphones, personal authentication, security, and surveillance, and even entertainment. This feature has tremendously improved our lifestyle in so many aspects. Your favorite applications such as Instagram or Snapchat scan your face and add a layer of filter to spice up your pictures. Your e-wallet application scan and recognize your face for two-factor authentication, which puts a second layer of protection to your security. But how does a machine recognize a human facial expression? For human, we effortlessly recognize simple shapes to complex form in an instant, thanks to our eyes and brain that perfectly captures and process visual information. For machines, facial expression recognition was done by using handcrafted features such as HOG, SIFT, and LBP, which is local binary pattern. So let's talk about LBP. Local binary pattern is an intensity-based feature and it is widely used for its computational simplicity, where it calculates image pixel values and extracts its data to represent the image information, usually in a histogram. Because an image consists of pixels and each pixel holds a certain values, these values can be altered. If we look at two images of human face with an expression, one doing his or her normal face and other is showing a sad expression, we can see the difference between them because a person with a sad face may show their lips pouting outwards and their eyebrows will be lowered and pulled closer together. That is a few of examples of how we human needs to see in order to differentiate one expression to another. Instead of seeing the whole face to identify an expression, what if we could only focus on the important parts of the faces that makes up the expression? A researcher developed a facial action coding system where this framework describes human facial expression based on action units, which are related to the movement of eyes, eyebrows, and mouth. This framework is utilized by numerous researchers in approaching facial expression recognition. Image difference-based method follow these steps in segmenting facial action units but with different approach. Image difference-based method take the difference between two expressions so that any part of the face that does not involve in the expression will be discarded, remaining only the important parts. These parts will be then processed by LBP for face recognition. So what is the next step? First, what we need is an image database. The database should have the subject doing several facial expressions, and these images will be used to train and test our facial expression recognition program. The most important expression is normal or neutral expression so that image difference can be applied. I have downloaded Yale Face Database, which there are 11 images per subject, one per different facial expression, which are happy, normal, sad, sleepy, and many more. Furthermore, I also made my own database by capturing 20 UTM students' facial images with 5 different expressions. Next, the images will go through several processes or filter before LBP expression is made. This is to ensure that we can record the accuracy improvement for each filter that we apply. The first filter that the image will go through is changing the image to grayscale, since LBP needed grayscale images to extract the information. Next is face realignment. In this process, the subject face will be identified and placed on the center of the image. This is the most important filter to make sure that the effective image difference method can be done. This is because in the image difference method, we need to take the difference between two images. Any slight alignment issues or image distortion can render the method inefficient. Moving on, a technique called canny edge detection filter is also applied to extract useful structural information and reduce the amount of data to be processed. By using this filter, only necessary part of the face, such as eye, mouth, nose, and other, will be left to be computerized. All this filter and recognition was done by using Python programming software. For facial expression recognition program, there are two separate folders labeled testing and training. In the training folder will contain another 5 folders which are folders of each expression, which are happy, sad, sleepy, surprised, and wink. In test folder, there will be only one selected image from the database for the program to predict the expression. The images chosen was at random. 20% of the database are used for testing and other 80% is used for training. However, in every test, the images of the subject that was used for testing will be removed from the expression folder it was in. The accuracy of each method tested will be counted by dividing the correct prediction with the total of subject tested. The Yale face database and UTM database are divided in the training. When testing of a subject from Yale face database, only the Yale face database will be used for the training. The same procedure are also used for UTM database. There are 3 steps which are the accuracy were taken. First was direct LBP, realign, and image difference. In direct LBP, the image does not undergo any filter or changes before extracted by LBP. Realign is when the faces in the image are centered and aligned. The result is displayed in a line graph of accuracy versus method. The y-axis shows the accuracy percentage, while the x-axis shows the method it was applied. During the direct LBP, we can see that both Yale face and UTM has the same accuracy of 26.7%. After the images were realigned, the UTM database has slight increase to 30%, while the Yale database shows a decrease in accuracy. But after image difference method was applied, the two database shows a significant increase in accuracy. Overall, the image difference-based facial expression recognition does improve the accuracy of the prediction. The decline in accuracy when realigned process was applied could be caused by nature of random sampling that was done. Random sampling is done so that the sample will be representative of the larger group and less likely to be subject to bias. Yale database is also small and have variety of ethnicity and complexion, and race, gender, and age have strong impact in the face structure, which could disturb the training process of machine learning. And because it has small database, means less feature that can be extracted. For better and effective facial expression recognition, the database should have the subject making the expression uniformly. This is to ensure that the expression information can be uniformly extracted. And not just that, lighting is an important detail to be considered, because good illumination ensures that the facial part on the subject are light up well. Lastly, I want to say thank you for lending me your ears for this 10 minutes presentation, and also thank you to my supervisor and my friends that helped me throughout all this final year project. I hope you understand and have a great day.